Good day, everyone. So my name is Gobe Hobona. I work for the Open Geospatial Consortium, also known as the OGC. So I'm going to talk to you about optimizing interoperability between location-aware platforms through OGC API Standards. First, an overview of the OGC. The OGC is a standards development organization. We have more than 500 member organizations from across the globe. They come from government departments. The organizations come from various aspects of the industry, including government departments, private companies, research institutions, and other academic organizations. Our mission is to make location information more findable, accessible, interoperable, and reusable. And we do this by providing a collaborative and agile process that combines consensus-based standards, innovation, and partnership building. So, more than 80% of data used by decision makers contains a reference to a location. This is a code that has been used over a number of decades in various research journals. The key point regarding this code is that it highlights that more than 80% of data contains either a geographic coordinate, a postcode, or some form of place name. And this is data that decision makers rely on. Location-aware platforms that support these decision makers rely on APIs to support the exchange of data between those platforms. As the number of platforms and the number of APIs has increased, so has the need to offer standardization for how those APIs exchange geospatial data or any form of location reference data. So the OGC has responded to that need through the development of OGC API Standards. If you're wondering what an OGC standard is, an OGC standard is a document established by consensus and approved by the OGC membership that provides rules and guidelines aimed at the optimum degree of interoperability in a given context. The photo on this slide was taken at an OGC member meeting back in 2018. The OGC holds about three member meetings per year, and in between those member meetings, we run several teleconferences which provide a platform for more than 500 member organizations to come together to discuss requirements and solutions for improving interoperability between different applications. This slide here shows an overview of the OGC standards baseline. OGC offers standards for data models, encodings, web services, and web APIs. The focus of this talk is on OGC API standards, but it's important to keep in mind that OGC as a nonprofit organization offers these standards free for anyone to use and for anyone to implement. So looking at OGC API standards, this slide shows an overview of approved and candidate OGC API standards. Starting from the top left and working our way down, we have OGC API joins, which specifies an interface for accessing feature collections that have been joined together. So joins in the same sense that one finds joins in relational databases, for instance. OGC API Discrete Global Grid Systems, or DGGS, specifies an interface for accessing resources that have been organized according to DGGS, or Discrete Global Grid Systems. These are partitions of the Earth or partitions of space into what are termed as discrete global grid systems, which are cells or zones at different levels of detail and typically in equal area structures. OGC API Records specifies an interface for accessing catalog metadata or catalogs of metadata. OGC API Maps specifies an interface for accessing electronically rendered maps and charts. OGC API Styles specifies an interface for accessing cartographic styles, symbology encodings, and so on. OGC API Moving Features specifies an interface for accessing collections of moving objects or collections of representations of moving objects. OGC API Tiles specifies an interface for accessing tiled data resources. Typically, those tiles are organized into tiling schemes following well-known structures. OGC API Common specifies the foundation building blocks on which other OGC API standards are implemented. OGC API Routes specifies an interface for accessing routing data, such as is used for transportation. OGC API Environmental Data Retrieval specifies an interface for accessing spatial temporal environmental data resources. OGC API Features specifies an interface for accessing vector feature data. OGC API Processes specifies an interface for accessing implementations of geospatial algorithms. OGC API Coverages specifies an interface for accessing coverage data, or such as, for instance, satellite imagery. OGC API 3D GeoVolumes specifies an interface for accessing 3D data. And then finally, OGC SensorThings API specifies an interface for accessing sensors as well as the observations that they collect. And this is typically in the Internet of Things. Now, these standards are designed in such a way that the building blocks that they specify can be integrated to address a variety of challenges or a variety of needs. This slide identifies the various resources that are offered by the standards that you saw in the previous slide. What's important to remember is that a software product can implement one or more OGC API standards in order to offer capabilities that address a variety of needs. And we've designed the standards specifically to enable the integration of those building blocks into those solutions. Each one of those standards offers an API definition document that's represented according to the Open API specification. And what you see on this slide is a screenshot of an API definition document specifically for OGC API Features Part 1 Core, which is one of the standards. So I've gone through each OGC API standard. What I'm going to now do is to talk about how a number of those standards optimize interoperability between different platforms. So OGC API Tiles, we'll start with that. OGC API Tiles enables access to tiled data resources through the use of standardized tiling schemes. If you're wondering what the structure looks like, there's an illustration on the right-hand side of the slide. Each one of those tiling schemes specifies how space or how an area can be broken down into tiles or partitioned into tiles at different levels of detail. And the standardized tiling schemes provide various parameters for, which coordinate reference system to use for those tiles and so on. Now, this standard enables implementations of the standard to support access to map tiles, vector tiles, as well as coverage tiles. So these are different types of geospatial data sets that are tiled. Now, this makes it possible to optimize the retrieval of tiled data in high bandwidth networks, as one would find typically in urban areas, but also it also supports the retrieval of tiled data in denied, degraded, intermittent, and limited bandwidth networks, such as one would find in rural areas, for instance. So this standard optimizes the ability of applications to publish and access different forms of geospatial data in various types of environments, whether with high bandwidth networks or in DDoS network environments. Here's an example of a case study. Ordnance Survey, which is the National Mapping Agency of Great Britain, has implemented OGC API Tiles on one of its products, and that product is the OS NGD API. And they use that product, they use that standard to enable the product to publish various forms of data through this OGC API Tiles interface. And that makes it possible for the customers to access a variety of data products efficiently. It makes it possible for them to optimize the data retrieval and the application of such data to address a variety of needs. So let's look at another OGC API standard, this time OGC API Environmental Data Retrieval. This standard enables access to spatial temporal environmental data resources, such as one would find in meteorological agencies or perhaps in aviation agencies or perhaps in geological agencies. So the standard enables implementations to support the sampling of multidimensional grid coverages. And such coverages include, for instance, satellite imagery or meteorological data sets and so on. And this makes it possible to optimize the querying of these coverages through standardized query types, such as position queries, area queries, corridors, trajectory queries, queues, and so on. The standard provides a consistent set of parameters for how you can query such big data stores using these query types. And this optimizes the ability of client applications to retrieve content or to sample a subset of those big data stores. And you can see examples of those types of queries on this slide. An example case study is the Meteorological Service of Canada, which has implemented OGC API Environmental Data Retrieval in some of its safety critical 24/7 solutions. And they've implemented this to support the publication of meteorological data or weather data. And this makes it possible to support plug and play requirements for different web applications. They are able to publish thousands of timed enabled layers for different regions, for instance, North America, as well as other parts of the world. And this supports applications such as visualization, animation, and so on. Another example OGC API standard is OGC API Features. Now, this standard enables access to vector feature data. And typical examples of vector feature data include, for instance, if you have any spreadsheet that has a column in there that provides a location, and that location could be geographic coordinates, it could be postcodes, it could be place names. That if you have any such data set, that is a vector feature data set. But also, if you have shapefiles, which is one of the legacy formats used across industry, that is a vector feature data set. And OGC API Features makes it possible to publish such data through an API that supports, that can be described using the Open API specification. And implementations of this standard support the querying, creation, retrieval, and management of vector feature data. And the standard enables these implementations to optimize how they publish structured data, whether it's from an object-oriented database or from a relational database or other form of database. But the standard also supports schemaless data sets as well. An example case study is the European Union's INSPIRE framework, which is a framework that has been established through the INSPIRE directive, which is an EU-wide law, a law applicable to all European Union member states, which describes how they should publish environmental data. So this is a law that supports environmental reporting across an area with more than 400 million residents. And the EU Inspire framework has adopted OGC API Features as a good practice for the Inspire download service requirement of the legislation. So this is an example of the impact that OGC API standards are having across the globe. An example implementation of this Inspire a good practice to use OGC API features is by a province in Germany, the North Rhine-Westphalia province, which has implemented OGC API features through an open source product called LD Proxy. And this has enabled them to publish an API for each one of the available data sets, which means they're able to describe the API using the Open API specification. They're able to publish the data using GeoJSON. Then they're able to to offer the data set using an API that is standardized and that is supported by a wide variety of software applications. So to support these implementations, OGC has published various compliance testing tools. These are freely available, so any software implementer can test whether or not the software product supports these standards. So we use an open source software product called Team Engine, which is also maintained by the OGC, but it's freely available and it's supported by a wide variety. In fact, it's supported by several different software developers from across the globe. And any implementer can go onto the OGC website and test whether the software product correctly implements the relevant standards. And they immediately receive a report such as shown on the right-hand side of the screen. And for a small fee, they are also then able to apply for certification. So they can test whether that product supports the standard for free. So that's a free service that OGC offers to the community. But the developers can also apply to have that product certified, and that comes at a small fee. There are various benefits to adopting OGC API standards, and this slide shows some of those benefits. First of all, they improve interoperability between various software products and data sources, but they also reduce the risk of vendor lock-in, the risk that an organization might get locked into a specific product or a specific vendor without the ability to move that data sources or to a different supplier. So OGC API standards reduce the risk of vendor lock-in. OGC API standards also accelerate the development of solutions, and they also reduce the cost of developing new capabilities. They make it possible for an organization to select software products from any vendor, from any organization, and to integrate those solutions in order to build larger systems that can address a variety of needs. And finally, OGC API standards improve seamless integration through the compliance testing and certification services that the OGC offers to the community. In conclusion, standardization is necessary to ensure that business processes are optimized, especially between location-aware platforms. OGC API standards are becoming a key requirement for any platform that handles, manages, or exchanges location reference data. And this applies to platforms that exchange data between themselves and other platforms, but also any platform that exchanges data between itself and human users as well. So organizations should specially enable their web APIs through OGC API standards to ensure that their data assets are findable, accessible, interoperable, and reusable. Thank you for listening.